Hello, this is Mr. Patry. I am talking to you today about error measurement, its propagation, and also significant figures, which we'll start off with. I think most of you have a pretty good grounding in significant figures from previous classes. Just do a real quick review here. I write down a series of numbers. Okay, so let's look at this first one. That has one significant figure, right? Because any leading zero in front of a number is not included as significant. So anything to the left of a digit is not counted when we count significant figures. So we just got the 4 in that first number. Below that, we just have the 4 there. That's leading 0. It doesn't count. So that's one significant figure also. On this 0.40, we have two significant figures because any 0 after a leading digit does count. That's why for 4.00, we have three significant figures. And for 4.0, we have 2. And 4, we just have 1. Now, if I were to try to add all these numbers together, which I don't have much room on the bottom of the page, but we can try. You can go ahead and keep all the digits. 2, carry the 1. All right. For addition, we look at the number that has the least significant digits. I'm sorry, not the least, but the least significant place, or the most significant place, I guess. This is the ones place. It doesn't have a tenth or a hundredth, just the ones place. That means any numbers to the right are not included, or should not be included as significant in my answer. Now my answer will have two significant figures because I had to carry the 1, so the 1 and the 2 would both be significant. But here's why I kept all those decimals, because that's going to round up to 13. So if I get all these numbers and I add them together, my answer should be 13. I should have two significant figures that comes from the ones place and the 4. All right, if you do multiplication, 4 times 0.04, that would be 6, 1. That would be correct with the correct significant figures. No, I'm sorry, it wouldn't. You take the number with the least amount of significant figures. The 4 just has 1, and that's as many as you can have in your answer. So again, I do the full math, but my answer is 0.2 with only one significant figure because I only had one number in the number with the least significant figures. I only had one significant digit. All right, so that is significant figures. Multiplication and division work the same way. Addition and subtraction work the same way. All right, now we're going to talk about uncertainty in our measurements. So, where to start? You see a shape there. That's a rectangular prism with the right cylinder out of it. So, we are going to measure its height, its width, its length, and also the radius of that cylinder. That's an R. All right. So those are all physical measurements that we're going to make with a imaginary meter stick. Up at the top here, I showed you the first 4 centimeters of a meter stick. Just to go over again how we take measurements with this. So I have this green object that I'm measuring, right? This is a meter stick, and I know it's not to scale on probably any screen, but this looks like 2 centimeters right here. switch colors. I have never used this screen capture before, so I'm not sure exactly what you can see. But that is 2 centimeters. Right, that would be 2.1, 2.2, then I'm somewhere between 3 and 4. When we make a measurement with the ruler, we always assume one more decimal place. So if this is 2.3 right here, to me it looks like it's going to be about 2.37 centimeters. Now, the 7, it is a significant figure, but it is not a figure with certainty. I'm pretty sure that number is going to be somewhere between 0.36 and 0.38. So that is why I add 0.01 uncertainty at that last digit. Could be a little higher, it could be a little lower, but 7 is a reasonable guess. Okay, and I'm doing this in centimeters. If I were doing this in meters, it would be 0.0237 plus or minus 0.0001 meters. Okay, so let's go to our shape here. Let's say I put my meter stick down, and I take another meter stick out. So this one comes out to be 33.42 centimeters. This, of course, is a meter stick. That is 100 centimeters. So let me write that down here with the air.
Technical difficulties. Please stand by.
0 centimeters. I know the meter stick is 100 meters long, but it has markings to the millimeter, which is here, and then I guess one more digit. And then I've got a plus or minus 0.01 centimeters. Why is that there? I know that meter stick is exactly 1 meter. That's what they told me when they sold it to me. Well, usually we don't have 2 meter sticks, right? So we're going to pick this one up and move it over here. And that 0.01 centimeters, it covers us to make sure we put it exactly where we were supposed to, and just to give us the error in the measurement. And we did that one, 33.4 was the tick, and then we guessed at that 2. We're pretty sure that 2 is a 2, but it could be a 1 or a 3. This is our height. No, this is our length. So when I add these two numbers, I add them the actual measurement and then the uncertainty. I add those separately. So I end up with 133.42 plus or minus 0.02 centimeters. Let's go in with the height. So I got 1 meter stick completely in there. So let me change colors again. Orange looks good. So my orange measurement, got 100.00 plus or minus 0.01. And let's say that we get 10 centimeters, a half, and then we guessed a 4. I've got 110.54 plus or minus 0.02. And we'll say that with the width, We got 1 meter stick on there that was a little bit longer. We got 98.36 centimeters. Never forget your units like I just did. Okay, so we got those three numbers. We know that the length is going to be the same for that cylinder. We have to measure the radius. So if I put my meter stick like that on the radius, let's say for R, one measurement, 26.41 centimeters. These numbers are, of course, made up. You'll use actual numbers, hopefully, that you measured from with your meter stick, or with another method of counting. If you counted blocks to get the height, you know that each block plus that course of mortar is going to have a certain distance. There's going to be an uncertainty there when you measure it. So then when you multiply that out, that uncertainty gets added for each block you counted. If you counted ceiling tiles, we can assume that those are 24 inches plus or minus 0.1 inches. If you're doing a conversion, you keep the same amount of significant figures. So if you convert that to centimeters, you can multiply that same conversion factor by the 0.1. Then you have to add that up for every ceiling tile. All right. The volume is going to be the volume of the block minus the volume of the cylinder. That's going to be HLW minus pi r squared h. All right. So H is 110.54. L is 133.42. And W is 98.36. I'm just trying to find the value here. I've ignored the air. We'll come back to that in a minute. But if I get my calculator out and multiply those three numbers together, I get 1450637.555 centimeters cubed. Probably don't need all those decimals. I know some of them are going to go away with significant figures. I have 4. So if I keep it with cubic centimeters, my answer is actually 1451. Because this number has 4 significant figures, and when I multiply numbers together, I go with the number that has the least amount, and I have that many. So, but I'm going to hold on to these other digits so I don't get any rounding error for a moment. That's right. Okay, now let's talk about the error. When I find error with multiplication, I do relative error. So I have 0.02 over 133.42. That is my relative error for length. I add that with the other relative errors. So I've got 0.02 over 110.54. And I've got 0.01, which I'm sorry I never put on there. over 98.36. Okay, took me a while to put that all in my calculator. So I am back now. Now I've got to add all those together. Which I am doing. Now what I saw, the people that attempted to do this, is they forgot the last step. I add all these together and I get 0.0004332. That is not the total error from my multiplication number. I have to take that number and multiply it by whatever I got here. So then I've got 14,506.40. Basically, I'm just going to truncate that to save some time. Plus or minus. When I multiply that times that, I get 627.50. Remember, that is centimeters cubed. If we go back and look at this, I've got R, which we said was 26.41 squared. I've got H, which was 133.42, and pi. Pi is a constant, so I use as many decimal places as I need. I think 3.1415. I'm going to use that many because that's all I can remember right now. Multiplying that by 26.41 times 26.41, and then multiplying that by 133.42. My total number is 292,344.4. The relative error, that was 0.01 over 26.41. Since that is squared, I multiply that times 2, and I add 0.02 divided by 133.42. I've already done that math. That was 0.000149. And 2 times 0.01 divided by 26.41 is 0.0000757. I add those two numbers together. I'm sorry, this is really boring, but it is necessary to get the right amount of air propagated through. 907. Now I multiply that. Got 265.15 as my error. All right. If I want to convert cubic centimeters to meters because it's more manageable, that's going to be 1.45. I'm just dividing by a million. 06 plus or minus 0.000 6275. And then I'm going to subtract off my cylinder. I'm in meters cubed. Again, I can convert without changing anything as far as air. 0.0002615. Now here's the last tricky part, I think. 4, that's a 5. I subtract these numbers because it's a subtraction problem, but with air it's plus or minus, so I always add air. So if I've got, get rid of that guy, so I have the same amount of decimal points. 2 carry 1 is 9, 8, 0, 0, 0. Meters cubed. One more step, and that is to get the right amount of significant figures. You remember we started with one significant figure for the air. And when we added our air all together, we had air in the hundredths place. And our relative air, therefore, when we start dividing, should have no more than one significant figure, because that 0 does not count. So I get to round that guy to 0.0009. The other number, see, we had 2 decimal places. So I had 5 significant figures. So when I multiply, I still have 5, which is what I kept. And I don't know what's going on here with my screen. I should have kept some more to make sure I didn't round on there, but it's been a long day and I don't want to do this anymore. So understand that if I had another decimal point out here, it would be better, another decimal place, so that I know if that 3 would round or not. Let me rewrite that so that it's legible. So for our practice problem here, that is my correct answer with the correct amount of air, 1.1583 plus or minus 0.0009 meters cubed. Again, I could change that to centimeters cubed if I want. I would have 1,158,300 plus or minus 900 centimeters cubed. I hope that was helpful and not too super boring. I know it's a lot of math. I'll see if I can edit out some of the long, boring pauses of number punching to make this video a little more palatable. That's all there is to it. Again, let me highlight the big things. Always have one more significant digit than the division lines on your ruler. Carry all your decimals all the way through until you go down to the correct number of significant digits. When you add or subtract, if you're subtracting, you still add the error. And when you're multiplying, you use relative error, but when you calculate the relative error, you have to multiply that by the actual value to get your error. All right. Thanks. Let me know if this works. We'll do more. Otherwise, have fun. Bye bye.